Hi, welcome back to another set of notes. Today we'll be addressing that thing that we talked about, which is matter, which is what chemistry is, the study of matter and its interactions. We'll talk about some changes to matter and go from there. So it's all about matter. I guess you could say it matters. Too soon? All right. Basically, everything that we know is made up of matter. All right. Matter is basically anything that takes up space and occupies space. Okay, so matter is all the particles that make up us and everything else. Okay, there's some specific types of matter. I already talked about elements a little bit, and so a couple other ones are atoms. Okay, an atom is a basic type of matter. All right, remember that an atom is smaller than an element. An element is made of atoms. Okay, and so an atom is the smallest particle of an element that still retains properties of that element. So in other words, carbon, atoms have properties of carbon, the element. Hydrogen has properties of hydrogen, and so on. All right, other types of matter are molecules and compounds. All right, molecules are atoms that are chemically joined together. We call this chemically joined. It's a fancy word for bonded. Okay, so there's a chemical bond that holds one or more atoms together. That's called a molecule. So we'll be looking at a lot of molecules in here and how they affect the body and cells. Okay, another term is called a compound. A compound is very similar to a molecule. In fact, it's a type of molecule that has more than one element joined together. Okay, so a compound, and again that joined means bonded. Okay, so compounds are types of molecules. Okay, I think that you've probably studied this since about second grade, but we'll just address it. There are two types of changes to matter that are important to us. They are physical changes and chemical changes. Okay, so physical changes are changes that are concerned with states of matter. And so basically you're just changing the state of matter or the phase of matter that it's in. All right, so for example, crushing a can, melting an ice cube, or breaking a bottle. Okay, these are all physical changes. They're changes in the state of matter that it's in, or the appearance of it, things like that. And so physical changes have a couple of rules. Okay, number one, they're usually reversible. Okay, number two, it's a change in appearance or state. Okay, and so those are just physical changes, things that you can just change their appearance and they go right back. Okay, so those are physical changes. We don't necessarily focus a lot on the physical changes in biology, but it's important to know the difference. Okay, the other type of change is a chemical change. Chemical changes take place on a molecular level. Okay, so you're way down at that molecular level looking at the atoms and the molecules instead of just its change of state. We're not looking at temperature or size or anything like that. We're looking at how did the molecules change? How did that bond change? Okay, so you're changing bonds and atoms. Okay, so examples of chemical changes are combustion, which is burning of anything. This is a combustion right here. This is the Hindenburg, if you've ever heard of that. Hindenburg were the blimps back in World War I and II, and that one actually caught on fire. Okay, cooking an egg and rusting of a nail are all examples of chemical changes. Okay, again, the requirements of chemical changes. One, these are not reversible, at least not in any ordinary terms. You've got to do something to it. You got to do a reaction of some sort. Okay, usually they're an actual change to the substance. All right, so really you're getting a new thing out of it. All right, and lastly, usually there's some sort of energy that is released as a result of this change. Okay, again, that's because you're changing bonds and rearranging bonds and things like that. So that's a big deal. Okay, so a little bit about molecules and compounds in terms of how they're made and how they look, just so that when we see them we know what they look like. Okay, a molecule is formed when two or more atoms join together chemically. So here's a nitrogen to nitrogen bond. Okay, and so there's a bond right here, the holes in this is obviously a cartoonish picture. If you were to draw it, it would look something like this. You just draw end to end. We add like a little line to show that bond, and the element itself represents the atom. So very simple. Okay, a compound is a molecule, remember, and it contains at least two different elements. So here's an example of a chemical. This is a very large carbon-based molecule. It's probably some sort of sugar. And so you can see that this one's got carbon, oxygen, and hydrogen all bonded together in different forms. Okay, and you know, these are chemical changes to make these things. So if you're rearranging the molecules. Now, it's just important to note that the amount of carbon, hydrogen, and oxygen in this and the order that it goes in, who's bonded to whom, determines what molecule it is and can change it. So if I just change this O from here and put it over here, that would change the molecule completely. That would be a chemical change. All right, a little bit about classifying different types of matter. We talked about two different classifications of matter. One would be pure substances, the other would be mixtures. Okay, a pure substance basically is a substance that has one uniform construction. Okay, in other words, it's made of the same thing throughout. All right, it's made of the same thing throughout. Same substance. All right, so it's important to note that elements and compounds and molecules, of course, are pure substances always because they contain the same thing throughout. Again, I'll use salt, NaCl, is sodium chloride throughout. It's uniform throughout. It's all the same. Okay. Mixtures are different. A mixture is a physical change where you're going to take two or more pure substances and you're going to mix them. Okay, so it's hard to not use the word mix to talk about mixtures, right? But you're going to mix them together, and so it is not the same substance. It's not uniform throughout. Okay, easy way to tell if it's a mixture is, can you separate it, you know, easily with any non-chemical form? Can you just, you know, for example, salt water would be a great example. Salt water is a hard one because it's a liquid and it looks like it's the same substance throughout, but really it's salt and water. And you can separate those. If you let the water evaporate, you'll be left with salt. So that's a mixture.